In this next session, we will use WaveGen to generate frames that would be specifically used for testing radio performance of a design of an access point or a client device. We'll start by opening up WaveGen. It'll ask us what type of card we're using. You can see that we can use a WBW 2300 or 2600 or any of the RF cards. So we'll use the RF 36014 because that's the card that we have. We'll connect to the chassis in the normal way. 192.168.254.46 is our card. And we can see that that chassis has an Ethernet and an AC card, an RF 36014. So either by going to the Actions, Reserve Port, or right-clicking, we can reserve the port. Now, WaveGen takes advantage of the real-time packet capability, packet generation capability, and the ability to change things on a per-packet basis to create any stream of packets in any combination that the user desires. So this is much different than the mental model that one would use when they were thinking about using a vector signal generator. A vector signal generator only works by playing out a file that has been previously created in software. This tool does not use any pre-created IQ file. It simply uses the real-time packet generation of the card, and you're using this application, WaveGen, to simply describe to the card what sequence of packets you want coming out. So let's do that. After we've connected, we go then immediately to sequences. In this transmission mode, we're going to generate packets. We can choose the channel, or we can set center frequency. In this case, let's choose channel 64. And we can set up channel models, but let's just go simply through and set up a couple of cases where you see how easy it is to generate the packets that you want. So you press the plus, and that gives you a first step in the sequence. Now realize we can have many different steps in our sequence, and we'll show you how that works. So I'm just going to move things around a little bit here so I've got a little bit of space. So let's say first we're doing initial testing of a receiver on a reference design. So for sequence 1, we say, gosh, I just want to send 10 frames in. I want those frames to be spaced together as closely as possible. So we're just going to put a very large number in at the rate, and that'll bring the gap down to the minimum 16 microseconds. Now we could change that rate. We could say, gosh, we'd like 1,000 packets per second, and it will space them out accordingly. But here we're just going to say we'd like to hit it with the fastest series of packets that the standard allows. So this will just automatically default the gap to 16 microseconds. Here we can set the transmit power for those 10 frames. Let's leave it at -6 for now. Now we are able to choose what PHY type. They could be legacy frames, HT, or VHT frames. Let's leave it at VHT. What do we want for signal? Well, we'd like to have 80 megahertz 3 spatial streams, let's say, at MCS 9, right? And in this case, we'll leave signal duplication, offset, preamble, and all that just where they are to default. So what I've defined just by clicking in these boxes are the physical characteristics of the packets that are going to be generated. The next thing I'll do is go down to the packet content editor and describe what would I like to see in the payload. Well, I'd like to see maximum length frames, so let's go 1518 bytes. I'd like for it to be random data. I'd like aggregation, and we should have the longest frames possible, let's say, with minimum spacing. So now when I click generate, it will automatically generate the packet content for me. And again, I could have had them be fixed at all zeros, or all one. So it gives you the ability to very easily, just with a few clicks, define what it is you want coming out of the front of the RF36014. So let's go random here. I'm going to click run once, and I'll explain this in a minute. So now I've done these things. If I go up here and press the green button, I've just run those 10 packets out. So it's as simple as that. There's no programming. I don't need to know how to run MATLAB or Signal Studio or any software that creates IQ waveforms and go through the complexity of downloading them. I simply need to know what are the frames that I want. Now, on the diagnostic side, if you are testing, let's say, a chipset, you would have some console into your chipset, and you would be able to see, did you receive 10 frames? Let's say you received 9 frames, and you thought, well, gosh, now I want to vary something and see why I didn't receive all 10 frames. Is it a signal power problem? So you can simply change the signal power and run it again. Go look, did you get 10 frames? Oh, well, maybe that wasn't it. Maybe you're concerned that it's a phi rate problem. So you can very simply go here, change the phi rate. Now you're running again. Gosh, that didn't work that well. Let's go back to MCS 9. Let's try 2 spatial streams, 80 megahertz. And off we go. So my point here is that as you are diagnosing and troubleshooting, one of the problems with vector signal generators is how long it takes for you to do the next experiment that occurs to you. And here it's very simple. You just point and click. So you can do all the sleuthing that you need to. If you wanted to change the length of your frame, maybe it's a long frame issue, maybe it's a short frame issue. Now you can go and take a look at that. Now that's your ability to adjust and troubleshoot one given situation. Now, let's see how easy it is to create diversity. So let's say we're receiving our 10 packets and we at MCS 3, 80 megahertz. Now we're curious, well, what happens if we get 10 of those packets at that power and then some other signal at another power level? So we can just click the plus, add another sequence, and let's give it 10 more packets, again at maximum rate, and we want those to be minus 50 dBm. And let's say they're also going to be 3 spatial stream, but they could be anything we want. So you see my point here is the ability to just create any sequence very quickly is at your fingertips. So we'll do 64 AMPDUs, 15, 18 byte frames. So just by these few clicks, now I just ran 20 frames out, 10 at minus 6, 10 more at minus 50. And you can look in your diagnostics on the console to see, did you get 20 frames? If you didn't, you can start modifying anything you want about the frame setup in order to rerun this. If you want a continuous stream, let's say now we're saying, well, gosh, I wonder how dynamic range works on this receiver. Let's send 1 frame at minus 6 and 1 frame at minus 50 and see what FCS error rate we get. Now we can unclick run once, let's say, and this will just continually run those 2. Now this is something you cannot do with a vector signal generator because it cannot change power level on a per packet basis. So here we are sending out 1 frame at minus 6, followed by another frame at minus 50, followed by another frame at minus 6, minus 50 continuously. Now you can check to see what your FCS error rate is. If you have FCS errors, you can come in here and start changing these power levels around until you can diagnose what the problem is. Right? So the simple method here is that you can dream up any kind of test that is important to your receiver testing protocol, create those frames, any number of frames, whatever your phi rates are, change those things around, If you're sleuthing and you want to know what happens between a VHT frame and a legacy frame. It's very simple to make those changes and then just run the next test. So what WaveGen does is harnesses the real-time packet generation capability of the WaveBlade that is unique in the marketplace and gives you an application here where you can very quickly, without having to be a DSP engineer and understanding the complexities of using software to create IQ files. Now you can simply follow a test plan and go do the analysis that is important to you for looking at a variety of diverse signals being sent to your receiver. In any one of these, remember that this card family has the capability of changing the characteristics of the transmitter on a per packet basis. So if we chose here, we could run one channel model on one sequence type and a different channel model on another, right? So if we wanted to see how does our receiver work when there are VHT frames coming in at channel model A, and let's say MCS 23, well, we'll make it even a little bit lower. MCS 17 frames coming in on channel model D at a different power level. That can be done for, so no other tool in the marketplace can change the channel model on a per packet basis and map them to individual clients. So we could build a sequence here of 500 individual steps because the architecture of the card has 500 unique client contexts. So any sequence that you can imagine that would be important to you, you can create it a packet at a time, some number of packets at a time, change power level from one step to the next, change channel model, change the payload type from one to the next. Now the definition of channel models here are the IEEE channel models, and they either will remain static on every frame that is sent, static cycle, which means they will change parameters, but they will only change from one packet to the next, or time variant, which says that they will change asynchronous to the frame rate itself. So as someone is diagnosing how well their receiver works, they'd want to start with a static model, make sure that things work correctly at the receiver for all of the different phi rates and all the different channel models. Then see that by changing the parameters of any given channel model on a frame by frame basis, the receiver continues to work. And then when we can introduce asynchronous change of the parameters, the coefficients, as the frames are being transmitted. This allows you to diagnose problems with your receiver capability. There are advanced things that you can do. You can set up your own OFDM custom scrambler seed. You can adjust the post encoder impairment, enable and disable the OFDM interleaver. These would be things that a baseband engineer might be interested in controlling in order to tell what's going on with their receiver. So this is how WaveGen works for you. It has the capability also to save each configuration. You can save that as a file, and you can run WaveGen from the command line. You can write scripts that will open up a config and run the application with that configuration. So a person can build an entire device qualification set of programs using WaveGen by using WaveGen to generate the combination of packets that you're interested in, and then scripting into your device under test to have it tell you how many frames it was able to receive. So this is WaveGen used on the RF cards. Unique in the marketplace, no other product can give you this level of diversity on a frame-by-frame basis, and it harnesses the real-time packet generation capability of the Ixia Wi-Fi product line.